Yeah.
Do you want to snuggle? Snuggle.
Of course, I always love to snuggle. It's my
With
favorite.
a blanket because my feet feel like.
Are they cold? Oh yeah, they're freezing. They're like icicles. Welcome everyone to this video. We're going to do part 2 of Tic Tac Toe in Python. In the first video, which I'll link in the description and in the cards in the video somewhere, what we did was we created Tic Tac Toe when we played against a computer, and the computer generated its position based on randomness. So that was the first easy way. In this video, we're going to do something a little more difficult. And what we're going to do is change the computer algorithm to first check if they can win. And if they win, then play that marker. And then if they can't win, check to see if they can block the player. And if they can block the player, then play that position. And then lastly, take a strategy of playing corners, middle, and edges, which is this next optimal strategy if you're playing manually. There is a third and better algorithm called a minimax, which would do a better, even better kind of recursion tree, but that's a little more difficult. So that's going to be for another video if I get to that. So in this video, we're going to do the more of the manual method of having a computer AI play against us. So a lot of these steps I'm going to skip that I already covered in the first video. So if you want to know those, reference there. But mainly I'm going to focus on how the computer has a better AI in this game. But I do want to kind of go over those steps again because I did it differently. I had to change some things around. So first we're going to import random. And this time random's only going to be used for telling who goes first. We're going to switch up the first player. And then I assign the player letters of X and O for computer letters. So we're going to go ahead and statically assign those. And then next one we're going to do is define the board. And we did that by saying board, position, and loop for I in range of 1 to 10, or up to 10. All right. So yeah, reference these functions in the other video if you're not quite sure what they do. The next one is print the board. So print board, and we'll pass in position. No, we don't want to print that. Actually, I'm just going to use my reference here and briefly explain it. Out of the way. All right, so what I'm doing here is I'm printing, this is the manual representation of this list here. So the list is just numbers from 1 to 9 basically that we're choosing from. This is gonna print it out manually so we can see it. So I just have a string of hashes there to separate between them. And then position 1, 2, 3 is on top, 4, 5, and 6 is in the middle. And then 7, 8, and 9 is on the bottom. They're separated by hashes in between, and pipes is our vertical spacers. So that's what the board looks like when we print it out to see the results or to find out where we need to play. All right, the next one is going to be the full function, and this is going to check to see if our board is full. So essentially, it's going to look for open spaces. If there are any, then it will not be full, so it won't return. But if it is full, then it will return that it is full because there are no empty spaces. The next one is a little optimized from my video in that I am going to check for who's the winner. And this time we're going to do a check win. We're going to pass in the board, which is this string of numbers. And then we're also going to pass in a letter, which is, we're going to call that later on, but essentially that is our player letter. And so that could be the computer or it could be the player. And we're going to check to see if that matches any one of these combinations. So 1, 2, and 3, that's on the top. 4, 5, and 6 is in the middle. 7, 8, 9 is on the bottom. 1, 4, and 7 is on the left vertically. 2, 5, and 8 is the middle vertically. 3, 6, and 9 is on the right vertical. 1, 5, and 9 is diagonal to the right. And 3, 5, and 7, well, 3, 5, and 7 is the vertical on the right. And then 1, 2, I don't think we need 1, 2, and 3 again. Huh. Yeah. Interesting why that's on there. We should have a total of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 8 possibilities. All right. The next one we're going to do is check to see if a position is free. So this one is if we are going to play, we first have to see is it empty, because we can't overwrite or make a change to the existing position. So what we're going to do is have a function called isFree. We're going to pass in the board and the position that we give it when we ask for that position, and we're going to return the position if it is free. And if it is free, then yes, we can play at that position. The next one is going to place the marker. So when we go to run it, we're going to ask, is it free? And if it is free, we're going to place that marker. So we're calling this one place marker. We're going to pass in the board, whoops, and then we're going to make a mark, whichever position that's going to be, in the position that we give it. So actually our mark would be X or O, and in the position at the board. So that's the making the mark on the board. All right. And the next one is the player turn. This one also is the same. I didn't really make many changes to this one, but I'll step you through how this one works. So the player turn, when we call that, we're going to ask for an input of an integer for that position. What do you want for your play? So we'll print the board, show you, and then first we're going to do a number of steps. We're going to try first is if it's free. So that's if free we defined here. The board in the position that we just asked you from 1 to 9. So if it is free, we'll go ahead and place that marker on the board with our letter, which is X, and that position that we just gave it. We're going to put that on the board. If it's not free, then we're going to give you back a message to say, hey, this is not free, try again. So we'll run the player turn again. The except here is if you don't put in a variable between the board position, between 1 and 9, essentially it's going to say, hey, your number is not between 1 and 9. Please try again between 1 and 9, and we'll play that one again. So that's the player turn. And now let's go to the computer turn. And I think we'll do this one in real time so we can kind of explain how that works. All right, so let's do define computer turn. And what we're going to do is we have the real-time board, and what we're going to do is create a copy of that board so we can simulate a run. Because the first one that we want to do is check to see if the computer can win. So let's imagine we have a X on the first top 1 and 2, and then we want to place an X in 3. So what we would do is we'd take a copy of that board and we would loop through each one of those positions and check to see, is there a winning position? So in this case, we would loop through 1, well, it's already taken, loop through 2 is taken, loop through 3, oh yes, we checked win, 1, 2, and 3 is a win, so we'll go ahead and place that, and we won. So that's kind of what we're doing, is simulating that run. So we need to create a copy of the board so we can loop through. So before I define the computer turn, we need to define a function that says duplicate board. And we'll pass in our normal board. And in order to do that, we'll create an empty list and we'll call it duplicate. I have board for reference here. And then we'll do a for I in board. So we're going to loop through our original board and we're going to duplicate append. So basically we're going to take every position within the original board and add it to the duplicate board, and then we'll return the duplicate board. So this is basically our copy. So now we can come down here and we can start our for loop. So we'll for I in range of 1 to 10. So we're looping through these numbers. And where do we want to loop? Well, we have to define our variables inside this function. We'll call it duplicate board. We'll call this function here of our original board. So we'll create a copy. And now we're going to loop through that copy. So what we can do is first we want to check is free. So is the position free that we're looping through in the position? If it's free, then we will want to go ahead and place a marker in that copy of the board in that position of I. And then we're going to check to see if it wins. So if it wins in that copy of that computer letter, then we can go ahead and place the marker on our original board with the computer letter of the position that we are running through. So then essentially we'll run through that one more time. So we'll take a copy of the board, and then through each iteration of that, say 0, 1, 2, 3, etc., is it free? If it is free, then go ahead and place a marker in the copy and check to see if it's a winner. If it's a winner, okay, great. Then we'll go ahead and place that in the original board. But what if it is not free? And so if it's free, if it's not free, basically we'll just continue through the loop. All right, that's really all that we need to do to check to see if it's a winner. And then the next step, here I'll go ahead and put some comments here. Check if computer wins. And then down here, we are going to check if player wins. So essentially we're going to do the exact same thing. We're just going to change a couple things. Maybe pause the video and see if you can determine what's different here. We don't need that variable again. I've already called it. All right, so for I in range, if is free, let's see, we need to indent all that. Place marker. Instead of computer letter, we want player letter. And same thing here. Instead of computer letter, we want player letter. So essentially the difference is we're going to go through the same loop of 1 to 9 and check out if it's free. This time, instead of placing an O, we're going to place an X. And then we're going to check to see if X is a winner. And if X is a winner, we want to block them with our letter. So that's what that does right there. And then we'll continue on through the loop. All right, so that's the first two winning strategies that go first. Now, if neither one of those are the cases, we'll go ahead and keep going and do our strategy to play corners, middle, and edges. All right, let's make sure we're starting in the right place here. All right, so what I'll do first here is I want to find the possible moves through an array here. So I'm going to build out a new array and find out what is basically available or empty. So there's an easy way to do this, and this is called a list comprehension of how we would loop through. So we could say 4x in range, actually 4x, and then comma letter in enumerate. So enumerate is a way to basically display all the valuables of the board. So we'll take in board, and then we will say if letter is equal to, so if the letter is empty and x is not in the 0, then we're going to say also x not in 0. I think that's all we need. Then what we'll do is return x. So essentially what we're saying is enumerate everything from the board. If it is empty and it is not 0, then go ahead and give us the result. And that would give us a possible move. So we're going to use that list here. And we're going to build out a couple more. We're going to call the next one corners. And those are the possible corners, 1, 3, 7, and 9. We'll also do the edges, which would be 2, 4, 6, and 8. The middle, we don't need to build a list for. We'll just call that specifically. All right, so now we need to do a couple of loops through each of these. So first we want to basically check to see, here's what is available to move in. So we want to check to see if any of these corners are available to move. And if it is, we'll go ahead and play it. So we'll do a loop. So for I in corners, and guess what we want to check? We'll say if I is in the possible moves that we've extracted, then we'll go ahead and place the marker on the board with the computer letter at the position that we are looping through. And then, I'll go ahead and return this. Okay, so if it's not corners, then let's do the next one. We'll do the middle. So if is free, and we're going to check the board at position 5. So the middle, check to see if that's free. If it is free, then go ahead and place a marker down on the board with an O at the position 5. And then our last one, we're going to do the same thing as we did for the corners. We're going to loop through the edges this time instead of the corners. And then we'll say if anything in edges and is in possible moves, we'll go ahead and place the marker on the board of our letter O of the iteration that we are running through. All right, that should do it. So just to recap, we have the first block here. What that does is check to see if there is a possible win and plays it. If not, then it'll move on to the next block to see if there's a possible other player win. If it is, it'll block. And then it'll take the strategy of playing the corners. Then it'll play the middle and then the edge. All right, now let's go ahead and build out the run. This is a little bit different than my original, just because I just took a different approach. And so let's quickly run through that. So this is our run game. So first, I'm just going to run it in main. Okay, so first let's print a welcome message so people know what we're playing. Welcome to Tic Tac Toe. Oops. All right. And then let's get the spelling right here. Okay. And then, yeah, we're going to go ahead and print the board that way in case if it is... No, actually, before we print the board, let's define the turn. So who goes first? So that would be our function that we built, who goes first. We're going to call that, set it to turn. I believe we have this defined, yes? Do we have who goes first? No, we didn't build who goes first. Okay, let's add that one. So define who goes first. So basically what we'll say is random. We're going to choose a random 0 or 1. If it is 0, then we're going to say return player letter. Player letter. Oh, no. And then else would be computer letter. All right, so now we'll randomly choose who goes first. All right, now we can start our loop. So our game is now going to start running. So while true. And then any time that someone wins or there's a tie, it'll exit out of the loop, game will be over. All right, so first we'll say if turn is equal to player letter. I don't want to tab it because it's going to give me everything at this point. All right, so player letter. Then we are going to do the player turn. Actually, no, we're going to print the board first because we need to see what's available before we play. So print board, and then we can do player turn. So once we have played, we always want to check if there's a win, and we also want to check if there's a full. So we'll check win, pass in the board, pass in our letter, and we'll say, we also want to print the results in case we did win, and say you have won. And then we'll break out of the loop, and the game will be over. Else, we want to check if it is full. Actually, we're going to need another statement. So elif. So the next condition is if it is full, then hopefully this will all make sense. So if it is full, then go ahead and let's print the board, show the results, and we will say it's a draw and break out of the loop. And then lastly, we can say else is turn is equal to computer letter. And so it'll switch turns and go on to the next. So let's define the computer turn. So if it's not player turn, then it's going to be computer turn. So else, everything inside of that, we're going to go ahead and do computer turn. And we'll do the same thing. We want to check if there's a win, pass in the board, pass in the computer letter. If there is a win, we want to print it, show the results to our user, and say, sorry, you have lost. And then we'll break out of the loop, game over. The next one, we'll check to see if they haven't won, then is it full? If it is full, we'll print the result and show them it, tell them it's a draw, and break out of the loop, game over. And then lastly, we will switch to the player turn. All right, so that is essentially the same thing. Here's our player and then a computer, and then it flips, goes from computer back to player. So it flip-flops. All right, and then I think all we need to do is call our main so we can run. All right, let's test it out, see how we did. Hopefully we don't have any. Oh, yeah. Oh, yeah, looks like there was a problem. Okay, well, let's see.
You're going to draw with me when I'm ready?
Yeah, I do.
Do you really want to?
Yeah, I want to draw with you when I'm done.
But do you really want to?
Yeah. Fortunately, I'm going to have to debug. And the best way to debug is just print out, or take a guess on where it's failing, and then print out that line and see if it's running. Great. Find the next line break, print that out. Is it running? What is it outputting? So that's what we're going to do. Where I think the problem here is that we're going to print a line here, and we're going to say, corner is free. And then here we're going to say middle is free. And here we're going to say edge is free. So let's see if we run that. It is not doing any of those. It is not even getting into this function here. So let's come up to here. And let's see, it's got to be placed on a marker somewhere. Let's say possible winner. And then let's go to this one here and print possible blocker. Okay, let's run it now. So it is thinking that's a possible blocker. That's what's playing. So what is wrong with our blocker? Because we don't have a possible winner. So let's make sure that our blocker function is correct, or code. A player can win. So for I in range 1 to 10, copy. Oh, you know what? We do need, I took this out. We do need to make another copy. We cannot use the existing copy that we used in this function. We got to reset that. All right, so let's run that now. Okay, so it took the corner this time. Yes. And if I play now, it's okay. So now it's going to take the other corner. Great. And then let's just be easy on the computer and go ahead and play a losing game, and it should pick the win. Yes, it did. So we chose, it picks the win. All right, let's go again, and we want to try to have us block us. So we're going to play a little bit better strategy here. So there's one, it picked a corner like it's supposed to. We'll pick the bottom like it was supposed to, so it blocked us there. We're going to pick the center. It blocked us there. And yeah, it should end up in a tie now. We're going to block the computer, so we're going to do 6 and then 8. So the draw is working. So let's see if there's anything else we needed to test out on the computer. So it is checking to see if the computer can win. Yes. Checking to see if we can win. Yes. And then playing corners. Let's double check this again to make sure it plays corners, middle, and edges in that order. So we'll run it again. So corners, yes. Let's go. There's the next corner, and then it played the win. So it is playing corners. Edges is going to be very rare. Just to make this a little bit easier in the game of Tic Tac Toe, essentially the strategy is to pick the corners first. That is generally the better strategy, and then the edge, and then the middle, and then the edges. One other thing that I could do that would be helpful, that I think that would be a better strategy. This is a great position if you are the first player. If you are the second player, then you actually want to do the middle first, because you're playing defensive, and then you would do corners and edges. So what I could do is say, if my player goes first, then do the defensive strategy by doing middle, corners, and edges. If the computer goes first, just follow this strategy: corner, middle, and edges. All right, well, that's going to do it for this video. Hopefully you found this helpful, and leave any questions, comments you have. And, I might be done with this one. I might come back and do the mini-max at another time. Let me know if you'd like to see or hear more about that. Thanks for watching, and I'll see you in the next video. So long.